All right, in today's lesson, we're going to be learning about how to compute a linear regression by hand. So the reality is computations like this are almost always done by a calculator or a computer because there's sort of a lot of steps and there's a lot of moving parts, but we may occasionally need to show our work for this, or we may want to sort of understand how our calculator or computer is sort of doing this and how it's coming up with the values that it gives us. So that's what our lesson's going to be about today. But before we get started, let's go ahead and take a deep breath and let's get into it. Okay, so I like to start all of my math lessons with sort of like a definition, right? And so I want to remind everybody or let you know, in mathematics, the word regression is essentially the process of trying to find a relationship between an independent variable and something that you suppose or that you think is a dependent variable. So in this particular lesson, we're going to be focused on linear regression. In other words, taking a bunch of data and finding the best line to fit it. But I want you to know that other types of regression exist. Quadratic regression means if you have a bunch of data that sort of looks like it's in a parabola shape, quadratic regression can be used to find the best parabola that fits that data. For logarithmic regression, if you had a bunch of data that sort of looked like it was on a logarithmic curve, you could use logarithmic regression to find that. You don't need to know anything about those right now. I just want you to know that they exist. Today, we're really just focusing on linear regression, the easiest of them to work with. All right, so this is sort of one of those terrifying slides, right? At this point, you want to just sort of run screaming away. There are 10 steps in the process of doing this linear regression. It's not hard, but it's time consuming. So I want to go through these with you. I'm not going to spend a ton of time here because this is already in the notes, but I want you to have a sense of what we're doing. I really believe that these first two steps are arguably the most important ones that you do, particularly when you're doing this in the context of science or a scientific exploration. You need to start by identifying one of your variables as the independent variable. In other words, the one that we don't really have any control over. It's the one that we think that the other variable is depending upon. Okay, so you're going to choose one of them as the independent variable, and you can name that anything you want. For these steps, I'm going to be calling it x, but the most important part is that it's going to be plotted on the horizontal axis of your graph, and it really could be any letter. So if you're using precipitation, you could use P as your independent variable. If you're using rainfall, you could use R as your independent variable. If you're using temperature, you could use T as your independent variable. It doesn't have to be X. We just are comfortable with calling it X because it's going to be the horizontal axis of your graph. Okay? The second step is that your other variable is going to be the dependent variable. In other words, your second variable depends on what your first one was. Okay. Now again, for these steps, I'm going to be calling this y, but just like before, it can be any letter, and when you plot it, it's going to be on the vertical axis of your graph. Okay, so your first two steps aren't a ton of work, but there is some thought that goes into it. Okay. The third step is you need to compute the average or the mean of your independent variable, and you're going to label it x bar. Okay. Now again, if you're using a different variable name, maybe you're calling it t bar or p bar, I'm going to use x bar right here. This is the standard mathematical notation for the mean or the average of a variable. Okay. Then, next step, and there's going to be a table for this. I'm going to show you a way to sort of like work through this. Your next step is for each value of your independent variable, you're going to compute the difference between the average value you just found and the value of your variable. So you're going to compute x minus x bar. So you're going to take one of your data points and subtract the mean. Take another data point, subtract the mean. Okay. Step 5, you're going to square each of those differences that you found and add them all up. And that thing that you find, that sum, is going to be called SSXX. Just trust me, that's what we're going to call it. Okay. Now, we're actually going to do really, really similar things again, but now with the dependent variable. Okay. For step 6, you're going to compute the average or mean of your dependent variable, and you label it using the bar notation. So again, y bar, or maybe you'll call it t bar. Sort of whatever your dependent variable is, you're going to put a bar over it because that's the mean. Okay. Similar to step 4, now for each value of your dependent variable, you're going to subtract the mean from that value. Okay, and again, we'll put that in a table. Then similar to 6, we're going to square each of those differences that we found, and we'll add them all up. Okay. Then similar to before, we're going to label this thing SSYY. And actually, I just realized that this was actually step 5. I changed my step numbers at some point. Sorry about that. We're going to use that number later in the lesson. We're actually not going to use it right now, but I wanted to have it now. Okay. Step 9, oh my gosh, we're almost there. Step 9, you're going to multiply together from your table each pair of your x minus x bar and y minus y bar, and then you'll add all of those products up, and you'll call that thing SSXY. So when you square the independent variable one, we call it SSXX. When you square the dependent variable one, we call it SSYY. And when you multiply together the x1 and the y1, we call it SSXY. Maybe you can see why we use that notation. Maybe not the SS part, but the XY part perhaps. Finally, now that we've done all of this stuff, there's a fairly straightforward formula that we're going to use to actually find our equation of our regression line. Okay? So the slope of your regression line is found by doing SSXY over SSXX. And then to find the vertical intercept of your regression, so your y-intercept, you do this computation right here. The average of the dependent variables minus the product of the independent variable, and then this slope that we got from before. And then when you're all done, your regression line is basically y equals mx plus b. Remember that your y variable and x variable may have different names based on the data that you're working with. So I'm sorry that it took me a few minutes to sort of tell you what all the steps are. We're now going to walk step by step through each part of this process so that you'll have a really clear picture of what it looks like to do this. Again, I'll admit it's a little bit tedious. Fortunately, you're likely to only need to do this once or maybe twice in the course of sort of like an investigation or a process that you're using mathematics to do. Actually, before we get into that, let's take another deep breath because I know that was a lot. All right, now let's try putting this into practice. All right, so I'm going to try this for a small set of data. Okay, I don't want this video to be too long. Okay, so as an example, suppose that the temperature, T, measured in degrees Fahrenheit, and the precipitation, which I'm going to call P, which is measured in millimeters on 6 days, are recorded to be these things. Okay, so I've got this table, we've recorded some data. Steps 1 and 2, you remember, are where you identify an independent variable and a dependent variable. And I don't know that there's necessarily a right or wrong answer in this. It's a question of how you want to say it. Maybe you think that the amount of precipitation there is depends on what the temperature is. Well, if that's the case, you would say that this is the dependent variable and this is the independent variable. At the same time, someone else might say, no, I really want to think about this as saying that the temperature depends on the amount of precipitation, right? In that case, you would say that temperature is your dependent variable and precipitation is your independent variable. For the purposes of this example, I'm going to say that temperature is the independent variable and that precipitation is the dependent variable, just so that we're sort of all on the same page. In your exploration, it's valuable for you to talk about why you're choosing that. Because this is sort of a disembodied problem, I'm not gonna say that here, but that's an important part of what you need to be doing in your exploration. Sort of why did you choose what you did? Now, I'm going to do things a little bit out of order here. I want to do steps 3 and 6. Okay, so for step 3, I want to compute the mean value of the independent variable. So I want to compute t bar. Okay, so how do I find the average of these things? Well, really simple, right? I just add up 65 plus 70 plus 68 plus 59 plus 72 plus 66 and divide this whole thing by 6. All right, so I got that this was 66.6 repeating. Yay, that's step 3. Okay, we're going to continue on here. Step 6 Step 6, again, we're doing a little out of order, but it'll be helpful. Step 6, I want to compute what the average of my dependent variable is. Same deal. I'm going to add up all of the values that I have and divide by the number of values that I have. And the value I got for this was 3.6 bar. So we're going to be taking those values and we'll be using them in just a minute as we work through the other steps. Okay, now when we're working with a process like this where there's a lot of steps and we have to repeat a lot of the steps over and over and over again, it can be really helpful to sort of have a table to organize your information. Okay, and so, the table that I have here, there's nothing like magical about this. It's not like, oh, you always have to write it like this. But it can be really, really helpful to have something like this. Okay, so in steps 3 and 6, like step 3, I'm going to write down here. I'm going to say, T-bar, the average temperature we found by adding all these things up and dividing by 6. So when I did that, remember that I got 66.6 bar. And then over here, I'm going to put what step 6 was, right? Where I added up all these dependent variables and I divided by 6. I averaged them and I got 3.6 bar. Okay, so now I'm going to go back to steps 4, 5, 7, 8, 9, and oops, I just realized I had misnumbered this one, also 10. And I really, really, really want to encourage you guys to pause the video in between each of these steps and make sure you're giving yourself a chance to practice it. Okay, so in step 4, you can sort of, look back on your paper and your wall of text of steps. Step 4, I'm supposed to take T and subtract the average off of it for each one of these things, right? So this first one right here is going to be 65 minus 66.6 repeating. Okay, and I'm not going to be able to fit the work for all of these, but when I do that, do you see how this is going to be negative 1.6667, like whatever you can fit in there, right? The next one down, I would do 70 minus this average value, right? So when I do 70 minus that average value, I'm going to wind up with 3.3333. So at this point, I want you to pause the video, fill in the other 4 values here, make sure that it's clear to you sort of how you're filling these in and how you're getting the values for step 4. Okay, so hopefully you found all these values on your own. I'm going to go ahead and go back and put these values in that as I found them. So this one was 1.3333, and this next one was negative 7.6667, and the next one was 5.3333, and the next one was negative 0.6667. Okay, so I've got all of these values now. Okay. Now step 5 is really, really straightforward. All I need to do for step 5 is I need to square all of those values that I just got. Okay, so this first one, negative 1.6667, when I square that thing, I wind up getting 2.7778. And then for the next one, when I square it, I get 11.1111. Again, I want you to pause the video, work through squaring these, make sure you're getting the same values that I got. Okay. Now remember, your values might be off by just a little bit depending on how much you rounded these things, but they should be close. The next one I got here was 1.7778. The next one is, well, this is a large number, 58.778. The next one that I had here was 28.444. And the last one I had here was 0.4444. Remember, the last thing that we're supposed to do in step 5 is we're also supposed to total this whole thing up. So when I totaled all these up, I got 103.33. And remember that this thing is the thing that we were going to call SSXX. But I'm calling my independent variable T, so I'm going to call this thing SSTT. And we're going to use that later. Okay, we're actually almost there, right? Now that we've done this, a lot of this is sort of just like repeating, repeating what we're doing here, okay? Okay, so next up, we're moving on to step 7. Okay, in step 7, I'm supposed to compute p minus p bar. So I'm supposed to take my dependent variable for each one of them and subtract what the average was. Okay, so again, pause the video, do these ones on your own, make sure that you've got the idea. Here I got negative 1.667, and then I got positive 2.333, negative 0.667, negative 2.667, 3.333, and negative 0.667. Okay, very similar to what we did before. I'm now going to go and square these values for step 8. All right, so again, pause the video, square these values, make sure you're getting the same things I am. I got these as 2.778, 5.444, 0.444, 7.111, 11.111, and 0.444. And then remember, at the end of this thing, I'm also supposed to add all of these things up so that I can get my SSYY. But again, I'm going to call it SSPP because P is my dependent variable. When I added all of these up, I got 27.333. Okay. Now, like I said, we're really getting close here. We're almost done. What I want to do now is I want to go through and do step 9. In step 9, I'm supposed to multiply together. Each of it's basically the blue value and the red value. The difference between t and the average and the distance between p and the average. Okay, so for this first one, I'm going to multiply this negative 1.6667 by this negative 1.6667 value. When I do that, I end up with 2.778, which in this case was coincidentally the same as that yellow value next to it. That usually doesn't happen. We're going to do that for all of the rest of these values going down. Right? So this next would be 7.7778. The next would be negative 0.8889. And then we have 20.444 and 17.778 and 0.444. Okay. And then remember, we're also supposed to add these things up. I just realized that gray is really going to be a bad match for that gray square that I put down at the bottom there. So this value is going to be 48.333, and we're calling this one SSTP. All right, so now we're at the final step of finding this linear regression, right? Of finding this best fit line. Okay, so to find the slope, right, to find my slope, oops, this is too much for me. I mean, even I can't spell at this point, right? So to find my slope, I'm supposed to do this. I'm supposed to do the SSTP, which was the gray value that I got, the 48.333 number, and divide it by SSTT, which was my green number. Okay, so 103.33. When I do that, I'm getting that this is 0.4677. Okay? This is the slope of my regression line. Okay? In other words, this is for those of you that want to hear this is y equals mx plus b, this is the m. Okay. Now, what about the vertical intercept? What about the y-intercept? Which in our case here is going to be a p-intercept, right? To find the intercept, the vertical intercept, right? We're told that we're supposed to use this right here. Okay? So I'm supposed to do p bar, which was sort of this value right here. Okay, so it's supposed to be 3.6 bar minus, and then I was supposed to use my t-bar value, right? Well, my t-bar value was 66.6 repeating, and then I'm supposed to multiply that by the slope that I just got, right? It came from 48.333 divided by 103.33. And when I do that, when I punch all that stuff into my calculator, the vertical intercept that I got here was negative 27.516. Okay, so now that I have those things, I can essentially write my y equals mx plus b. But remember, we didn't really use y and x for this problem. We said that our independent variable was t, and our dependent variable was p. Okay, and then I just need to go back and put in my slope and my y-intercept. Okay, there it is. That's my regression line. This is my line of best fit. Now again, calculators can do this in like seconds, but if we need to show our work, if we need to show where this is coming from, this is the process that we use to do that. Now, just a little more to tell you. In IB, we're about reflection, right? And so I hope that you're wondering, hey, how well did I do? How not even how well did I do, actually, no, not at all, but how strong is the relationship between these two things? If I think that precipitation is linked to temperature, and if I think one of them is dependent on the other one, I need to be looking at how well does my regression line fit my data? How strong is the relationship between these two variables? There is a way that this can be computed mathematically, and it's called a Pearson's correlation coefficient, and it's always denoted by the lowercase letter r. Good news, you're actually going to need to do minimal computation for this. We've done all of the hard work. Now we just get to have benefit from that. Okay? Here's the deal. The closer that this value is to -1 or 1, the stronger the relationship is between your two variables. So if your r value is close to +1, we say that there's a strong positive correlation between the two variables. So that means that as one of them increases, the other one increases. When one of them decreases, the other one decreases. If your r value, on the other hand, is close to a -1, we say that there's a strong negative correlation between the two of them, which means that as one of them goes up, the other goes down. As one of them decreases, the other one increases. So now all we need to know is, how do I compute this correlation coefficient? How do I compute this r? Let's look at that real quick. So good news, everybody. It's just numbers that we've already done before, right? We spent a bunch of time filling out that table so that we could figure out what SSXY were, SSXX, and SSYY, right? We did those things already. So all I have to do is plug those things in right here. Okay, so from the example we just did, and I'd encourage you, pause the video for a moment, go back, look and see if you can find those values. If you're feeling bold, calculate this on your own. It's only going to take a few seconds. Punch those numbers in and see what you get. So your SSXX number, which was our SSTP value from before, would be 48.333 divided by the square root of the SSXX, which was our SSTT, that was 103.33 times our SSYY, which was the 27.333. When you throw all that into your calculator, you find that your R value is 0.90945. Notice that this is close to +1, right? This is close to +1. Because of that, we suspect that there is a strong positive correlation between temperature and precipitation based on this data. So that's how we compute the correlation coefficient. That's how we sort of get a sense of how closely related our two variables might be. The last thing I want to do is actually show you this on a graph, just so that you can see it. It's going to be a real quick thing I'm going to show you. So here's how you might show something like this on a graph, right? You'll notice that I labeled these axes. I said that my horizontal axis, my independent variable, was temperature, it was degrees Fahrenheit. We used the variable T for this. Okay. And on the vertical axis, for the dependent variable, we used precipitation, which was measured in millimeters. I might put a P here to indicate that that's the variable. And you'll notice that I've got my points here, and I've got this best fit line, and my line is really close to my values. It feels like, yeah, there's a nice, strong, positive correlation between these two things. This is what this looks like graphically. So I know that that was a lot. I know that this is not a quick, simple process, but I hope that that clarifies what you need to do to find a regression line and a correlation coefficient. Remember, if you have questions about any of this, if any of it's confusing, let me know. I'm more than happy to help in whatever way that I can. Best of luck as you work through these and in all of your scientific endeavors.